from Tim Durham, and he's going to talk about engineering and environmental design of the Panther Island Mitigation Bank and the expansion.
Shepherd. Good morning, everybody. My name is Tim Durham. I've been doing environmental consulting in Southwest Florida for almost 33 years now. I spent the first 31 years with a company called Wilson Miller, who was then acquired by Stantec, which is a large company. I stayed a while and now took a little time off, and now I'm working at Passarella and Associates. But I have a lot of history in the area. Panther Island Mitigation Bank was kind of a dream of mine back in the mid-90s. I saw a lot of mitigation that wasn't doing real well. You had developers who were forced to do mitigation as part of their permit. It's not that they didn't want to do well, that just wasn't their business. So we saw some mitigation efforts that were kind of half-hearted. Panther Island Mitigation Bank is a place where, as a business, wetlands are restored, and that restoration has a value that can then be traded to a developer for their impact. Grossly oversimplification, but 20 minutes you have to go kind of quick. Panther Island Mitigation Bank, the existing Panther Island is 2,778 acres. It was done in 7 phases. Those are all complete. The project met full success criteria and has been handed over to Audubon. Audubon now runs Panther Island Mitigation Bank, the habitat there. We have an expansion that's coming online now. It's about 1,700 acres. One of the phases is under construction on that. It's kind of exciting to see. This gives you a general idea of where Panther Island Mitigation Bank is. This is the Lee Collier line right there. We're sitting over here in the sanctuary. And so that's the original Panther Island in red. I'm going to focus on the marsh restoration at Panther Island Mitigation Bank. There are a wide range of habitats on the bank site, but there's about 545 acres that was previously a mix of wetlands and some uplands that was converted to agriculture a long time ago. When you're designing wetland mitigation, which is what I'm going to talk about mostly today, you know, it's hydrology, soils and chemistry, and of course context. My training is as a civil engineer. I was the civil engineer who got in trouble for missing class because I was out in the woods hunting and fishing all the time. So until I got in the workforce, I found out they pay you to do that stuff. You know, why didn't somebody tell me that when I was 16? It would have saved me a lot of aggravation in life. And what I ended up doing was kind of marrying my skills looking at water hydrology and surface water, groundwater modeling and all, and applying that to wetlands. And just some basic principles. We're looking at hydrology of the site. You look at the water inputs, water discharge, and the timing of those things. A little more detail on the inputs. Of course, you have rainfall coming down. You also have off-site flows coming onto the site from upstream properties. The other thing, like the layperson doesn't really hear about too often, is you have horizontal groundwater movement too. The water does move. Just because it's out of sight doesn't mean it's not there, especially here in Florida. Anybody knows you dig the tiniest of a hole down here and you find the water. So you have to understand what the water's doing below the surface to really model and understand the site. On the discharge side, of course, you've got, you know, the flows off the property. You've got the horizontal and vertical groundwater movement that you don't see. What are your tailwater conditions downstream? Where's the water going? If it's backed up high, obviously it's not coming off your site at the same rate. Evapotranspiration, and some properties, pumping is an issue with the hydrology. You need to know when the water is doing what it's doing also. That's very key. You know, we have seasonal rainfall patterns, which are totally being violated this year. Tailwater variations, evapotranspiration. It's a little bit more minor here than it is some other places. Up in South Carolina where I do some work, it's funny. During the winter, the water levels are higher. In the summer, they're lower. It's the opposite here. South Carolina, they have so much evapotranspiration that during that growing season for the trees and vegetation, they actually lower the water table. a very interesting phenomenon, kind of backwards from what I was used to when I got up there. And the other influences on timing is pumping, seasonal crop and agricultural practices. And you have to look around the property. You can't just look at a property. Agricultural influences to be felt for miles away. Either water being pumped onto the land and drained onto your site, or water being pumped out for irrigation lowering the groundwater table. So as an engineer, those are all the issues you're looking at. Soils and chemistry, that's kind of like electricity. It's magic as far as I'm concerned. I got through chemistry in college. I was not a big fan. It was too complicated for me. But it is important to understand what the soil and chemical characteristics are of the site you're on. You need to understand historically what was there, what's going on now, off-site impacts. For Panther Island Mitigation Bank, we had 3.5 acres of agriculture immediately upstream of the bank, and there was a canal dug through the property that's now the bank that went a mile and dumped straight into the cypress head in the sanctuary. So you really had to look at that water, what's come through that water in the past, what's coming through now, how do you deal with that? Again, soil and chemistry. For your bank site, you want to be able to have some really gorgeous wetlands grow. Well, you need some organics in the soil. You need that A horizon in the soil to really be established. You may run into marl or cap rock. Those are all issues that have to be factored in. And then context, the landscape setting of any site. I remember when I started doing engineering and environmental back in the early 80s, we tended to look at the site itself, and all the analysis was done on whatever site you're looking at. And over time, everybody got a little smarter and said, well, you got to look beyond the boundaries of your property to see what's going on. And that's very much more common now. You've got to look at the historic, the current, and potential conditions. The hydrology, what happened in the past, what's happening now. I have the word integrity there too, because you have to look at the water source and say, is that going to continue that way? What's the chances of it being interrupted by development or some other activity? Is DOT planning to, add huge culverts in 10 years, which will totally change the hydrology of the area? Again, under landscape setting, wildlife movement and utilization. Again, you have to look at the landscape scale. Where is your property? How does it fit into the puzzle? And then adjacent land use. Just because something's a farm next to you now doesn't mean it won't be something in the future. You need to account for that and figure out how do you deal with that when it comes up. The Panther Island site has some unique features. It was a very unique opportunity. We were able to convince a landowner to take a chance on doing a mitigation bank. I had the opportunity to fly in a helicopter and look at a lot of properties. Panther Island is unique in that it has a 4-foot slope across that site. And that's very important because you can drive water with that, which is something you don't have in a lot of sites. Within that 2,778 acres, there were 545 acres of agricultural land that had been farmed with an active perimeter berm, pumps, everything else. It was being used as a pasture when we evaluated the site. Its position within the Corkscrew Swamp Sanctuary meant it was just a very valuable piece. They served some good. The willing landowner, that was key. And then the regulatory community at that time, and I'm talking the late 90s at this point, we had a track record of successfully doing mitigation projects, and the regulatory community was supportive of the idea of trying to make a bank work out here. So all those came together really nicely. Once the project was set up, the landowner signed a deal to do this, and everything got going, something I call forensic ecology, which is always kind of fun. You go back and look at historic aerials and say, okay, what was here in the 40s, 50s, 60s, and kind of reconstruct the history of the site. And you learn a lot from it. You look at existing and past permits on the site, and then you look at past land use activities. The permits and the actual land use don't always match, so don't assume anything. Investigate all that and get a history on the site. This is kind of my editorializing, but there are a lot of mitigation banks in the United States. I've worked on several of them. I've done feasibility for some of the major oil companies in the Southeast on some sites. And simplistically, there's a continuum. Some are really good, some are really bad, some are successful, some aren't. The two extremes in my mind are the minimal investment kind of thing. Somebody wants to make dollars on mitigation banking with the least investment possible. The easiest way to do that is often to affect the hydrology. Plug up a ditch that's been overdraining a site, or get rid of some barriers to water movement to allow water to get onto a site. And if that's all you do, I heard somebody call it plug and pray. I call it hydrate and wait. Again, you're not being very proactive. You're just hoping by adding water back to a site that's been dry, it'll do great. And over time, that works, but it's a long time to do those changes. Fully invested is what I call somebody when you do some really detailed design and analysis of the site, take the time to understand what's going on and do the physical work necessary to accomplish your goals. I don't want to get into the finances of mitigation banking, but you're putting out a lot of money up front on this, and you have to wait before there's a financial return. So, the design elements, let's say we've assessed the site, we've got data, we want to design the project. Monitoring well data. The second that the deal was signed with the landowner to let us attempt to do a mitigation bank on their property, I called back to my office. I had 5 guys waiting with 28 wells, but they immediately ran out the site and installed monitoring wells across the site. At that time, we were going through a dry spell, and that weekend it rained, so it was absolutely perfect. We got the low water, we got to watch the water fill up on the site. It was just great timing. We take that data, do some groundwater modeling, and then we calculate some earthwork, how to recontour the site to get what we want. This is just quickly grabbed one of the wells from the expansion lands, but this gives you an idea what the data looks like. The red line is the ground surface, and you can see the blues above the surface. You get standing water at that particular well location. What people often miss is that the health of a wetland depends on how the water below the ground and what it does when things dry out. There's a mitigation site I'm trying to fix that I didn't design and do, but it has groundwater that drops 6 foot down below the wetlands for 6 months out of the year. The wetland plants don't survive that real well. So it's very important to understand what the subsurface is doing. We took this data, 28 different wells across the site. These are automatic wells that every hour recorded what the water elevation was, simultaneously for all of them. We also have monitored rainfall hourly. And when you get done, you have a set of data that you can create a contour map of what the groundwater is doing. Much like you have a contour map of the land, this is what you can't see below the surface, what the water contours are. And the shape of the land influences that table. And when we did the initial data analysis, we saw some unusual patterns in how the water was moving across the site. That led us to doing some borings, digging some pits, doing some analysis. We found there was a layer of marl about 5 to 8 feet down underneath Panther Island Mitigation Bank. That's significant because what that told us is water that landed on that site tended to stay on that site a little longer rather than dropping down. Also with the 4-foot slope, we were getting water moving horizontally from lands above Panther Island onto the site, moving across it, and then down into the sanctuary. So that led to some design decisions. At this point, as the engineer in me, my goal was to figure out how could we reshape the land, take those ag fields, scrape them down, rearrange them, work them so that we would end up with the right contours to create certain kind of wetlands. We worked with Corkscrew Swamp Sanctuary at that point. We talked to them about what some of their design goals were. Key, of course, is the wood stork. And you're going to hear a little bit more about that later today, but the ability of wood storks to forage at the right time of year is critical to their breeding success. And the way I explain it to people that never think about this stuff is, go back 50, 60, 70 years in South Florida. If you're a bird flying over it, you're seeing a million small wetlands everywhere. And some percentage of those are going to be the right depth for you to feed in. Okay? Time goes by, we lose a lot of the wetlands. And just as importantly, we have very homogeneous water levels. The ditches, roads, everything means that when everything gets wet, all of it gets wet. When everything starts going dry, it all goes dry. You don't have that variation the same way you used to. So it's either really good for wood stork or it's not good for wood stork. You don't have a lot of in between. So the goal with Panther Island is to create marshes that provided optimal forage opportunity in January, February, March, and April. So you have the design, and that's where the environmental and the engineering start marrying together. Yes, I can model what the water is going to do. We're going to change the groundwater contours. As soon as you do that, it changes how the water works, so it's kind of an iterative process to design elevations. Now you start saying, okay, with those elevations, how do we get our target wetland communities to work? And I'm going to kind of go quickly through this. Panther Island began construction in 2000. We used fuel load reduction for some of the burn areas because a lot of those hadn't been burned in so long. We had to provide an alternate flow route for agriculture to the north, which we did. But one of the key things was that thing about the soils and chemistry. You know, down here, if you kick the ground and go down 3 inches, you're into stuff that just doesn't grow a lot. And we didn't want to lose that top A horizon of soil. So what we did, we mowed the fields several times, disked that into the fields and did that over and over and over again, and then took the top foot of soil, scraped it aside, put it in stockpiles, and then did our reshaping, recontouring of the ground. Then took that topsoil, spread it back out. So now we have soil that's ready to support wetlands. Made a huge difference, and that wasn't common at the time. We ended up moving 900,000 cubic yards of dirt out there. And I meant to sit down real quick this morning and do a calculation how many football fields and how deep that is, but trust me, it's a lot of dirt. Well over 1 million plants were planted, and there's some plants being planted. When I retired from Wilson Miller Stantec, I put a lot of things in electronic files. I found some data corruption when I was trying to put this presentation together. I haven't recovered all my good photos. But this gives you an idea. They basically had rafts. This is after it's been recontoured, the topsoil has been put down, and they're planting. And there you see it starting to grow in. And we got a stamp of approval early on. And there you see it really starting to fill in. This is 6 months after the planting. It was amazing how fast this thing came in. And a good friend of mine was out on site, and when it was under construction, when they had stripped the topsoil, were recontouring with white sand, the wind was blowing, you're getting sandblasted. He goes, oh yeah, this is going to look great out here. Well, I brought him out about this point here about a year later. He goes, man, I didn't think this was going to work. He was just being a good buddy. You know? So it was really fun to watch his surprise. And there, this is, I believe it's 2 or 3 years after the initial planting. All right? And you can't really see the contours here and the variation stuff. And I apologize, I wish I had my good pictures. But again, the point is, the stuff came in quick. And the plant communities we targeted in certain areas, that's what stayed there, which was very rewarding. Because a lot of times you put in a mixture of plants and you hope one of them figures out what wants to be there and it kind of dominates. We got very accurate, and the communities we were looking for did become established. Again, that Panther Island was, in my mind, was done right. Of course I did it, so what else am I going to say? You know, economically it was a challenge because you put a lot of money in up front, and then the income you realize off each phase is rolled into constructing the next phase. And then the next phase. The next phase is at the end that you really see the financial reward. So I had the backing of some people who had a lot of trust this was going to work. It's worked. I said it's plus rewarding and fun. This was a personal project to me. I thought it was something that was kind of cool to do. Panther Island Mitigation Bank expansion. Working with Jason and other folks at Audubon, it was realized that we could take some of the property that was in Audubon ownership, but was so far out of their normal maintenance area, and we could go in and restore that and make that function much higher in the landscape. Same engineering principles were applied, but we used a little bit different design. Jason and Audubon's research on wood stork showed that the October, November, December foraging opportunities for wood storks were just as important as the winter months, which is something I probably suspected before but not proved. With that in mind, the wetlands being designed for the expansion, they're larger areas that concentrate down into small pools, and those pools would be available for wood stork foraging, like I said, October, November, December. And also, what happened with the original Panther Island, it was so successful, it grew in and it got so dense, it was actually hard for some birds to forage in there. So we tried to do a little different planting mix to keep some more open area, more opportunities. To date, we constructed a settling pond and a flowway to accommodate flows from neighbors to the north. I can tell you when we started the original Panther Island, as soon as we moved an inch of dirt, the neighbors all screamed that we were flooding them. Never mind, they had cypress trees in the front yard. So, the neighbors are always going to be unhappy, so we took care of that first. The initial phase, called Phase 8, has been treated, tilled, stockpiled, excavated, soil re-put down, and planting done. That was done a few weeks ago. And then the next phase, Phase 9, which is a very large area, will begin. We were going to do it the dry season this year. So maybe 2006-ish, I probably should have put it on there. We did a lot of Phase 8 in the wet, and the contractor hated it. So we'll see about that. And we also continue to collect data. Those monitoring wells are still out there on the expansion lands. And, we'll use that data. We'll analyze it as we go along. If we see we were wrong or modeled something incorrectly or see something happening we didn't predict, we can make some design changes. We're flexible that way. So anyway, thanks for listening. It wasn't very scientific, but I was trying to get an overview. And I do have some hard exhibits. Actually, I had to go to my garage last night to find them. But if somebody has questions for me later, they want to ask, I have some better exhibits to point to. Yes.
When you account for the pasture areas, were those historically wetland areas, or were they historically upland?
They were a real mix. And they had cypress head fingers of wetlands coming through, some of the upland areas. And when we were permitting the bank, we got into a long technical discussion, and we made the argument that it made more sense to replace marsh in those areas than some of the other things that people wanted. And part of the argument was we've lost so many of these marsh areas that if we could make some of those up on this kind of scale where we could manage water and figure out what it's going to do, it would make more sense. So no, we didn't try to replicate exactly what was there before, but there was a reason for that.
Yeah, and Tim, this is going to be a question, it's going to be a statement about that. And I wasn't sure, I didn't hear that you had covered that. This is really interesting philosophically, because lots of times we're in that mode of, you got to put it back to where it was. And my sense of what you guys said was, what do we need on a land that's been radically modified?
Correct.
So let's not worry about what it was, let's put it to a place where we need it. And that's a very powerful, different approach to the way we might be doing the creation that I personally think is good.
Well, thank you.
I agree with you about what you did on that land.
Good, thank you. And I think we've been borne out by history, but that was a very serious debate at the time when we were permitting. And that gets back to the regulators being intellectually honest and just listening to the counter argument to their initial position.
Okay, let's do one more question.
Can you talk about the high upfront costs? I didn't catch if this was funded by the private landowner or something else.
Yeah, I didn't know if I should even mention dollars anywhere in this equation. It's so
Sorry,
complicated.
I'm new to these parts.
Sure. Typically, a wetland mitigation bank is a commercial venture
Okay.
where the business is actually growing wetlands, getting credit for that, and then selling those credits. It's a business. So it gets away from the developer having to do mitigation, because they're good at building roads and houses. They ain't so good at growing wetlands, so we kind of treat that as a separate business. So that what the developer would have spent half-heartedly doing a wetland, that dollar gets focused on somewhere where it can really do something meaningful. And there's a whole complicated financial train involved there.
Thanks.
All right, thank you.